This is a good question because it allows you to see, do you understand the phrases that are being described here for bell work? Draw a graph from 0 to 5 for the following properties. F of 2 needs to be equal to 4. What does that mean? What needs to happen on my graph if f of 2 equals 4? There needs to be a dot. Go to 2, go to 4. There's got to be a dot. I have to have that dot on my graph because of this right here. Do I have to have a line that goes right to it? Doesn't have to. Okay, maybe it does, but not necessarily. We got that. This right here, the limit as x approaches 2 from the left is equal to 1. Anybody got an idea what that's going to mean? At 2, 1, I'm going to have an open circle, and I have to approach it. So I don't know how I'm going to approach it, but there's some line that's going to go away from that from the left, so that when I approach 2 from the left, I'm getting closer and closer to -1. I'm going to make this all into a graph eventually. It'll take some time. 2 from the right needs to be 3, so same idea. Here's 3, open circle to the right. I got to approach that number. It could be above, it could be below, but I have to have a line that goes up into that value. And then a limit of f of x, or I'm sorry, the limit as x approaches 4 exists, but it's not equal to f of 4. Anybody got an idea what that means? Jared, what do you think?
You could just, like have a straight line that goes through 4, but then an open circle at 4.
An open circle at 4. I got to have a line of some sort that's going to go through 4. As long as the left and the right side are approaching the same thing, the limit exists. Okay? But it's not equal to f of 4, so I just got to make a dot somewhere for f of 4. I'm going to just, because it is on the interval from 0 to 5. So, yeah, good. There's my graph. I got everything I needed. F of 2 is 4. The limit from the left side is 1. The limit from the right side is 3. The limit at 4 exists, but it's not equal to f of 4. I would, because yeah, it could be. I don't love that, but technically you could. I would say that description, you could maybe leave it not a dot. I don't. I just need it to exist. F of 4, it didn't tell me what it's going to be. It just had to be existing. All right, let's do a couple more quick reviews here because the quiz doesn't take real long. Try that one really quick on your bell work. Get an answer for that guy. Let's try it. So we set this thing up. We're finding the limit if possible. The limit as x approaches 1. We've got this thing times this thing, so we're going to find each of them. If I looked at f as I approach 1, what number would I get? 4. I'm getting closer and closer to 4. So that's 4 times g of x plus 1. So if I'm doing 1, it would be like 1 plus 1, so it's like 2. What is g at 2 going to get me? The limit as I approach 2. It would be d and e. So at first glance, you'd be like, oh, no, it's d and e. But we always need to look at from each side. So we want to find the limit as x approaches 1 from the left and see, is that equal to the limit as x approaches 1 from the right? It might be d and e, but we want to double check. Okay? It doesn't matter which side I approach f from. We said it was 4, so it's going to be 4 times this guy. If I approach g from the left, I get 1. 4 times 1 is 4. If I go from the right, it's going to be 4 times g from the right of 2 is going to get me -1. Is 4 equal to -4? No. So my answer, D and E. Makes sense what we're doing there. We look at it initially. D and E, great. It might be D and E, but we need to double check. Maybe it is, maybe it isn't. Let's try one last one. Okay, then we'll take our quiz. Find the limit as x approaches 2 of f of g of x. A little bit of a weird one here. Okay, a little bit different. We're doing a bunch of these problems. This is not the main idea with limits. They're going to have one of these on your AP exam. I think limits are fairly easy, and you guys are really good at them. And so by giving you the most challenging ones, you can see if you're really good at them. Don't feel like, hey, I'm not great at limit composition, so I can't do this chapter. Yeah, you can. You're going to be perfectly fine. You know the easy stuff. This is the challenging stuff. That's why I throw it at you. Okay, find the limit as x approaches 2. So I'm going to start off with the inside g of 2. As I approach g at 2, what's going to happen? D and E. So if it's D and E at first glance, then I'm going to look at the left and the right-hand side, see if it works. So we're going to find the limit as x approaches 2 from the left-hand side of g of x. What number am I getting closer and closer to from the left-hand side? 1. How am I approaching it? from the bottom. So it's 1 with a little negative sign of f of x. So I'm doing 1 from the left-hand side of f of x. So what am I getting closer and closer to? I'm getting closer and closer to 1. Well, no, what am I doing? 4. Why is it 4? My bad. Thanks. Sorry, I was drawing an arrow to the wrong one. I'm drawing an arrow to 1. Here's 1 right here. I'm getting closer and closer to 4. I wondered why my answer was incorrect. Then we're going to find the limit. As x approaches 2 from the right of g of x. As I approach g from the right, I'm getting closer and closer to negative 1. Great. Then I'm going to find the limit as x approaches negative 1. But how was I approaching negative 1? From above, so it's negative 1 with a little plus sign. Negative 1 from the right over here as I get closer and closer. Negative 1 from the right of f of x. I'm also getting closer and closer to 4. Since 4 equals 4, the limit exists at 4. Questions? A little bit of a challenge, but I like it.